top of it.
On top there. Yeah, so today we'll be looking at rectifier current limit. Here, just to draw the diagram for us to get it right. So here, this represents the rectifier. This represents the rectifier, and this represents the generator. So this generator, the rectifier here, the capacity is greater than the generator capacity. And if we peradventure will load this rectifier to 90%, and this generator, being that the rectifier is greater than the generator, it will cause an overload on the generator, and this is what we don't want. In order to prevent this from happening, we need to set the current limit on the rectifier so that we can use a portion of the generator, which is just 80% of the generator. To ensure that we use 80% of this generator, we must know the actual current that we can pull out of this generator, because the setting in the rectifier current limit is expressed in current percentage. To do this, let's go over to the next slide for us to get a clearer picture of what I am explaining. Looking at this here, we have a site detail here. The generator capacity is 16 kVA. The rectifier capacity is 18 kilowatts. The rectifier efficiency is 0.95, and the startup voltage is 47.5. So let's work with this data. Now, looking at this data, well, first off, we must convert the generator, because we want to use 80% of the generator. Now, this is the generator and this is the rectifier, and so we want to take 80% of the generator, 80% of this generator. In order for us to take 80%, utilize 80%, first off, let's convert the apparent power from kVA from kilo to kilowatts. To do this, we'll multiply with the power factor of 0.8, multiplying the value of 16 times, which is this 16 times the power factor, we have 12.8 kilowatts. So this 12.8 kilowatts is we are expressing it from kVA to kilowatts. Doing this, we'll now take 80% because we want to utilize just 80% of 12.8 kilowatts. Now multiplying this with 0.8, which is 80% of 12.8, we have 10.24 kilowatts. Now, this 10.24 kilowatts is alternating current. So for us to ensure that, we need to convert this to DC, because what the rectifier is using is DC, hence we will use the rectifier efficiency. The rectifier is going to take an input of AC and output DC. So it will take an input AC of 10.24 kilowatts and output a DC power of 9,728 watts. So this 9,728 watts is what the rectifier will take after taking this 10.24. It will output this power. And knowing that the current limit, using current, we need to express this in current, hence we will use the startup voltage. If we divide this power by the startup voltage of 47.5, we have a current of 204.8 amps. Now we want to calculate the maximum current at the startup voltage of this rectifier. Hence we have the rectifier capacity, which we will divide by 47.5, and we have this portion here of 379. Now, looking at this 379, it is obvious that if we are not going to set the current limit and we are operating on this 47.5, it's going to be drawing this much from the generator, and this will be an overload, and this is what we don't want. For us to be on the safe side, to take a portion of this of this, the 80% of this current here will divide the current coming from the generator, which is this one, the maximum current at 80% utilization, will divide it by the total current, which is 379. And when we multiply this, we have 54%. Is this 54% we will set in the rectifier? So we go to the rectifier and we'll scroll to the menu where we have the rectifier group, and we'll see the current limit. Then we can type in and punch this in 54% into the rectifier system. So like and follow for more video.